Hi guys, my name is Jimin, and I'll be talking to you about mimicry and flatworms and nudibranchs. Is this toxic or is this identity theft? So this is the outline. We'll first go over what exactly is mimicry, and then how did mimicry evolve, and why are these flatworms mimicking these nudibranchs? And we'll move on to the conclusion. So this slide just depicts a nudibranch on the left, a flatworm on the right, and you can kind of tell they look pretty similar. This is just one of the examples of how mimicry has evolved throughout the tree of life. There we have a caterpillar mimicking a snake, a fly mimicking a wasp, and then we have a praying mantis mimicking an ant. This shows that mimicry is highly widespread throughout all the lineages. So what is mimicry? Mimicry is an adaptation that allows one organism to resemble another, usually one that is noxious or inedible, with the intention of deceiving their predators or prey. In the case of prey, usually they would mimic something harmless. So model versus a mimic. In mimicry, there is always a model and there is always a mimic, which is mimicking the model organism. So you'll generally tend to find that the model organism has lots of bright colors and distinctive patterns, and the mimics, because they are mimicking their colors and patterns, they actually gain protection from this aposematic coloring. So here are some examples of nudibranchs and flatworms that are imitating each other. So aposematism. That is the use of warning coloration, such as bright oranges, yellows, reds, to deter potential predators from disturbing it, so basically from hunting it. They can be an indication of toxicity, unpleasant tastes and smells, and inedible materials. So the types of mimicry that are most prevalent are Batesian mimicry, so where an organism resembles a noxious organism to avoid predation. The Mullerian mimicry, where two or more noxious species closely resemble each other. And then aggressive mimicry is where a predator organism mimics something harmless in order to approach its prey and not be detected. So how did mimicry evolve? There's two parts. One is natural selection. So these aposematic preys, as they are brightly colored, they're obviously more easily visibly spotted by the predators. However, since they are very distasteful, they have a higher probability of being released unharmed. When the predator takes that first bite, they know that they don't want anything to do with it and they'll let it go, which usually results in a higher probability, again, of being unharmed. So you can see we have a fish, and that fish has the unfortunate luck to prey upon a colorful aposematic nudibranch, which resulted in its death. But if we rewind time, and the fish actually found a flatworm that is not toxic and is totally fine. So the second way is learned avoidance. So this is when predators learn from their mistakes. They learn that these colorful, brightly colored, noxious animals are actually not good for them, and they should prey on the less colorful, more likely not noxious ones. So again, they learn to associate bright colors with inedible organisms. So you see the fish has learned that this drab flatworm is safe to eat, whereas the colorful, brightly colored nudibranch is not. So then why do these flatworms make nudibranchs? As you may already know, some nudibranchs gain toxins through their diets, which makes them inedible to many predators. However, some flatworms also have these toxins. So then still, why do these flatworms mimic their toxic nudibranch counterparts instead of producing their own toxins? So some flatworms actually do have their own toxins, tetrodotoxin, TTX for short, which you might have heard. It's a toxin that's present in pufferfish. So oftentimes these juvenile pufferfish and other organisms known for their TTX, they will feed on these flatworms to increase their own toxicity. So you can see you have a low toxicity pufferfish, and it preys upon these flatworms that do have the TTX and their egg clutches, which results in them getting a higher toxicity. So research done by Ritz and Williams et al. In 2006 found results that due to the high predation of these flatworms that do have these toxins, it wasn't a very effective way to ward off predators, and instead they found it mainly as a way to catch their own prey. And then, however, when they did mimic more well-known noxious nudibranchs, they found that the protection rate was greater and that less of them were dying. So some of these flatworms can produce their own toxins as a mechanism of defense. However, that mechanism of defense isn't very helpful since they're being preyed upon for their toxins to replenish the predator's toxins. Therefore, it was found to be more advantageous to actually mimic noxious nudibranchs that their predators do not partake in their diet in order to better survive. And therefore, lots of flatworms decide to mimic nudibranchs instead of producing their own toxins.